Hello and welcome to another episode of We Should Code, and today we're going to be talking about what is a linked list. So what is a linked list? So the term linked list refers to a linear data structure where the elements representing the list are structured as nodes that typically have two parts. One, a data or a value, and then two, a link connecting to the next node. Typically, this type of linked list is known as a singly linked list, not to be confused with a doubly linked list, which we'll cover in another video. Okay. Basically, what you need to remember is its data value, okay, and a next button, basically, okay, which moves you to the next element within the list. Okay. So here's a flow chart showing basically your functionality for the parts that allow you to interact with your linked list. Okay, so you have your head, then you have your data value, then you have your pointer or your next pointer, and then you can iterate through each element using the next button, and each one brings up the data that's associated with that node. Okay. And you have the commands. You can either add something to the front of the linked list. You can have something follow a data value or element within the linked list. Or you can add something to the end of the linked list. Okay? So those are your three options to interact and alter a linked list. How do you insert an element into a singly linked list? Well, like I just covered, you can add it as following a given node, front of the linked list, or end of the linked list. You can add an element to follow a given node using this code as an example. Okay, so I'll let you look at this yourself. I don't like reading out code, but you can look that over and copy it and try it out for yourself. I encourage you to do so. One, you want to establish that there is a node preceding the node that needed to be added. Okay, you have to account for the new node's data. Okay. And then you need to swap the new node for the node prior to it. And that's all the functionality that's in this code. Okay. Next, you can add an element to the front node. Again, here is the code for that. In order to do that, you have to establish data for the new element, connect the new element as the head, and cause the new element to move to the head position. And that's what's covered in the code here provided. So adding an element as the end node, here's the code for that. You can plug and play and try that out for yourself. You want to establish the new node and data of the element, make the node to follow as null, and then you ensure the node will be the last node. Okay. So just to touch on the Big O analysis, which we'll be putting out a pretty good video on. Big O analysis in Java for the most part. It does correspond to other languages, but mostly Java for our purposes here. But in order to place an element as following another element, not front or end, it would require complexity of order of 1, okay? Which is the most basic, simplest order of complexity for code, okay? In order to place an element as front of the linked list, it would require, again, a complexity of order 1. Okay, and then in order to place an element as the end of linked list, it will require a complexity of order n, which is much more, well, not much more, but more complicated than order 1 at least, because it has to take into account the amount of nodes within the linked list, which requires you to iterate through, know how much or how many elements you have, which does require more complexity in that case. So this is an introduction to linked lists. We'll be getting into linked list, arrays, and other similar topics and what's dissimilar about them. Okay, and we'll give out some examples or have some examples down the road with some of our projects. As always, please like and subscribe to our channel for more content. Jets always needs friends, and he has a few but needs more. Take care and take care.